Okay, so before I get into the code of the experiment, let's talk about the experiment itself, right? Because we need to know what we're doing. Um, so for exercise 2, pretty much we're just going to be building upon exercise 1. So as you can see here, we still have the same predefined command functions as exercise 1, where essentially the LED1 will turn on when I insert the string into the termite command, right? It's basically going to tell the system what to do, right? So yeah, we're gonna have some predefined commands that we're gonna input into the termite function, and it's gonna do that, right? So again, if I input LED1 on, it's gonna turn that LED on. If I put an LED1 off, it's gonna turn that first LED off, and similar thing with the second LED. The new component though that we're gonna add to exercise 2 is we're gonna add the fan to it, right? And pretty much for this for the fan, we essentially have to input the command as fan semicolon, or actually colon, my bad. Fan colon is equal, fan colon n, right? So that fan colon n, where n is the duty cycle, right? So at which this it spins at that certain duty cycle. So again, once we know that it's fan and duty cycle, we know that we have to establish our PWM. Um, and so in order for us to set up our PWM and stuff, I'm gonna leave the link into the description, in the description, saying about how to set up that PWM in the code and all that stuff, and essentially all the setups again. But yeah, so essentially these are the predefined commands. Where again, the only new part that we're adding in exercise 2 is the fan. And essentially, if, for example, we put fan colon 30, then that means that the duty cycle has to be, or the fan has to spin at 30% duty cycle. And yeah, so let's get on to the code and let's see how to do all that stuff. Okay, now let's talk about the code for exercise 2. So I will leave a link in the description to the exercise 1, because basically we're just going to build upon the code for exercise 1. So if you haven't looked at that video yet, look at the video for exercise 1, because pretty much we're going to be using that code and just building upon that code for exercise 2. So, but real quick, I'll just give a real quick recap. So again, pretty much we have to establish um, our if statement with the state machine, basically that allows us to essentially to essentially be able to give the commands to the UART and then go back and forth, right? And then this, obviously the two states are the SIDL and then the SGOT data, right? So it's the communication between the two devices. And yeah, and then again we have initialized variables and all that stuff. And then pretty much for exercise 1, right? Pretty much what we're doing is we have this do command, which is essentially the command or the function that's essentially allowing us to tell the system what to do, right? So yeah, this is this do command, and again, this do command was enabled through our state machine, and yeah. So again, we have our strings, which basically, if our strings that we input, they're basically predefined commands. So if that string is basically like, if it matches the string that we input, then it's going to do the command. So again, they're predefined commands. But yeah, so these are pretty much the predefined commands for the LEDs, right? Which basically say if the string that I inputted matches LED1 on, then it's going to turn the LED on, and it's going to give me that response command saying what's happening to the system, and it's pretty much going to do the same thing. So if the LED1 is off, and then it does the same thing for LED2, right? LED2 turns on, it's going to give me the response. Yeah, and then for when the LED2 is off, it's going to give me that response, and it's basically saying that if the string that I input matches if it matches the LED2 off, then it's going to do the command, right? So that's pretty much stuff from exercise 1. So now exercise 2. So this is the part where we have to essentially add the fan, right? Because again, as I said previously, pretty much in exercise 2, we're simply just adding a fan to the system, right? To the code. So for this, right, when we're adding the fan to the code, pretty much all we're doing is we're going to add another else statement, right? And this else statement is basically stating that pretty much the way we have to do it is we have to essentially kind of break down the string into 2 components. So the predefined, again, as I previously stated in the video, the predefined command for essentially for moving the fan is fan, semicolon, and then the duty cycle, right? So essentially for that string, what I have to do is I have to break it up in 2 parts. So the first part, right, I have to basically say that if the string that I inputted first has fan in it, right? So if it first has fan in it, read the command until the string is up to fan. So I'm just going to read fan, right? And that's basically what's going to trigger this this thing to do, right? So as soon as it says, as soon as the system reads fan, okay, that's it. I'm going to essentially be able to move the fan. Okay, now we get into the more complicated part, right? Which is basically saying at what duty cycle to spin that fan. So essentially, in order for us to basically establish at what duty cycle, right, at what value the duty cycle is, we pretty much have to establish the delimiter, right, or the delim, as I stated here, and I initialize their variable over here, which is the semicolon, right? So once it passes that that semicolon, then we're going to use that number, right? That number after the semicolon, which is the percentage, and then we're going to set that equal to our duty, right? Because again, that number after the semicolon is our duty cycle. So we have to get that value, and essentially, once we get that value, we're going to plug that value into the CMP, into finding our CMP, right? And we know how to find our CMP from this equation here, which we previously learned in other experiments. And yeah, so that's pretty much it. So essentially what we're doing is we're breaking up the string into 2 components, and we're essentially reading that value in after the semicolon, and we're plugging it into this equation here, right? Which is basically the load, right? The load times 1 minus the duty, which is the value after the semicolon over 100, and then we have to establish our CMP. And yeah, and then we have to, again, for every single command that we do, we have to get a response back saying what's the function doing, and then we get that response back by the UART print string function, which is here. And yeah, so that's pretty much it. So now let's get on to the results for the experiment.
Okay, so now let's look at the results for exercise number 2. Okay, so pretty much what's supposed to happen is in this termite command window, I'm going to input these commands here in this order, and that's going to essentially allow for the fan that's here, and these LEDs right here to essentially turn on and turn off, and the fan is going to rotate at the specific duty cycles that is listed on this list right here. Okay, so let's see that happen, right? So first, in the termite command window, I enter plus LED LED1 on, and see, it gives me the response here. And if we look down here, LED1 is now on. See, LED1 is now on. Okay, So now let's see how to turn on LED 2. Okay, so see, it's only LED 1 that's off right there. Not sure if that's pretty visible, but we'll see right now. We'll see when LED 2 turns on. Okay, so now when LED 2, I'm gonna turn on LED 2 as well. So LED 2 on, right? LED 2 is on. See? So now if we look down here, both LEDs are on. See? Let me bring this a little bit closer. Bring this a little bit closer so you guys can see. See, the two LEDs are on. Oh, maybe that's a little better. The two LEDs are on. See? The two LEDs are on. Okay. Now, I have to input the fan to now spin at a duty cycle of 50%. So let's do that. So I'm gonna input plus fan, and then remember that whenever we're gonna input the a command into the termite window, we pretty much want to put plus, right? So let me hold this fan so that it doesn't hit anything. Okay, now I click enter. See, the fan is on 50%. And now if we look down here, the fan is, see, if we look here, the fan is spinning. It's spinning at 50%. See? I'm not sure if you guys can see that. It's spinning at 50%. 50% duty cycle. Okay, so now the list here, if we go back to our list, it requires us to turn the LED 2 off. So let's do that. Let's turn off the LED. So LED 2 off. So once I click enter, this LED here, there's the second LED is going to turn off here on the board here. On this board here, the LED 2 is going to turn off. So let's do that. See, it turned off. LED 2 turned off. Okay, now the list requires me to increase the duty cycle of the fan to 100%. So now let me input that command in the termite window. So if I input that command, fan 100. Oops. Sorry about that. I need to put. And see, as you could already hear and see, our responses here. If we look at the responses there, right, it tells us that the fan is on 100% duty cycle. Now if we look back at our fan here, it's spinning way faster, right? It's spinning at a very fast speed. You can even hear it. Okay, then from our list here, it says that we have to turn off our LED. So this LED here, if we look back here, I'm going to input these. Going to input that to turn off the LED, the first LED. So LED 1 off. See, LED 1 off. I'm gonna click enter, and the LED just turned off. So the LED turns off. Yeah. And now I'm gonna make this fan stop by simply inputting plus fan 0, right? Plus fan. Oops. Plus fan 0. See? So if we look at our command now, we are going to see that as soon as I click enter, right? The fan stops, as you could hear. The fan here stopped. So yeah, that's pretty much it. So essentially, the results for this experiment was essentially putting commands in the termite window here, and essentially being able to get a response from the termite indicating that certain components of our circuit is on, and essentially doing the command that it's told to. And yeah, that's pretty much it. That's that's everything.